Hey folks, Mr. Dell here. We are looking at a problem that has to do with exponential rules, exponent rules, and we're going to probably use each of the rules here that we have in play when it comes to simplifying exponent expressions used with exponents. So I'll rewrite these because I know it's kind of small here. So this is, by the way, this is CPM CC3, and this comes from, let's see, section 823, 8.2.3, specifically number 95. So part A is 3 to the 5th over 3 to the 10th. We've got a couple things in play here. So one of the things I want to remind you is anytime we're dealing with exponents, the fallback and the thing you can always do is just to factor it out and use the giant 1 to simplify. So I'm going to show you both. So in this case, if I factor this out, 3 to the 5th means 3 times 3 times 3 times 3 times 3, right? That's what 3 to the 5th means. Repeated multiplication is where exponents come from. 3 to the 10th would be 3 times 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 3. So that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 threes being multiplied gives you an exponent of 10, right? Repeated multiplication gives you exponents. So this is where you can now cross out using the giant 1. So I've got this 3 over 3 is 1, 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 3 over 3 is 1. So all of those are giant 1s that would simplify. So we look to see what's left. Well, on top, there's only 1 times 1 times 1 times 1 times 1, so it's just 1 on top, right? You always have something on top or bottom, and it's usually a 1, but sometimes that can actually simplify out. So now there's 5 threes left, so it's 3 to the 5th. So this simplified is 1 over 3 to the 5th. That's using the factored out form. The other form that we've got here is knowing that x to the a divided by x to the b is equal to x to the a minus b. It's our rule of dividing like bases, you subtract the exponents. So that's also possible. So if we were going to look at this problem again, and I'll show you what happens, we have 3 to the 5th over 3 to the 10th. If I subtract, right? If I subtract, I end up with 5 minus 10, which is 3 to the negative 5. If I subtract the top one minus the bottom one, I get 3 to the negative 5. And back from knowing negative exponents, what's true about negative exponents? Well, negative exponents create reciprocals, right? So creating reciprocals meaning if I have 3 to the negative 5, that is actually the same as 1 over 3 to the 5th, right? So 3 to the negative 5 creates reciprocals. It makes the number smaller. So you multiply instead of by 3, it's 1/3, right? So another way of looking at it is 3 to the negative 5 is actually 1/3 to the positive 5. It creates reciprocals. So 1/3 times 1/3 times 1/3 5 times gives you this 1 over 3 to the 5th. So that's another method, another way of looking at it. All right, so let's keep going. Let's do B. So B says 10 to the x to the 4th all times 10 all to the 10x all to the negative 2. Okay. So once again, there's this concept of we've got negative exponents, we've got just a standard positive exponent. So what do I have? Well, I could go about this a couple ways. What I like to do is I'll take my negative exponents if possible and make it positive first, right? So when we have this negative 2, right, negative exponents create reciprocals. So what I can rewrite this as is this is 10x to the 4th, and it's times 1 over 10x. That negative 2 applies to both the 10 and the x. 1 over 10 all to the second. 1 over 10x, sorry, all to the second, right? That 10x becomes in the denominator. Okay, or we can also look at it this as just immediately that whole thing goes to the denominator, right? So we end up with 10x to the 4th over this 10x all to the second, right? When you have a negative exponent, it creates reciprocals. So that everything in parentheses here belongs to that -2. So all of that would be all in the bottom now with a +2. All in the denominator with a +2. It creates reciprocals. So let's simplify this out. What does this mean? This means 10 times x times x times x, right? There's 4 x's. The 4 only affects the x here, not the 10, because it's not in parentheses. The 10 is a single 10. And on the bottom, 10x squared, all this 10x all squared means, oops, let me move that over, sorry, means 10x times 10x, right? Because the 10 is affected by the squared, by the 2. So now I can actually just cross out giant 1s, right? So there's a giant 1 of 10s, there's a giant 1 of x's, and there's another giant 1 of x's. So what's left now is on top I have 2 x's, so it's x squared, 2 x's being multiplied, over 10, only a single 10. So that's where that answer comes into play. Okay? So let's keep going. Let's go with C. C is, I'm rewriting it so you can see it, 1/4 to the third times 4, and put it in parentheses, to the second. Okay, so again, now I'm looking at, I've got this 1/4 all to the third. If I just multiply this out, that would be one way of doing it, is just write it all out. So 1/4 to the third means 1/4 times 1/4 times 1/4 times, and then 4 to the second means 4 times 4, right? So it's 1/4 times 1/4 times 1/4 times 4 times 4. Remember, when you're multiplying a whole number times a fraction, you put that whole number over 1. So both of those become 4 over 1, 4 over 1. So really, if you want to write this, you could write it as one fraction. It's 4 times 4, because all that 1's just stay 1, and then over 4 times 4 times 4. That's another way of looking at it. And now we can actually cross out some giant 1's, and my final thing is 1 over 4. I still have a 1 on top. That's one way of looking at this problem. I want to show another way. We talked about negative exponents create reciprocals. Well, the opposite's true. If I make this the reciprocal, it could make it a negative exponent. So just for the sake of seeing other ways to approach this, here we go. So 1/4 is the same thing as 1/4 to the +3 is the same thing as 4 to the -3, right? The reciprocal of 1/4 is 4. So once I change that to be the reciprocal, the exponent changes its sign. And then that now is 4 to the -3 times 4 to the second, which now you have like bases. Remember the rule? X to the a times x to the b is equal to x to the a plus b. When you multiply like bases, you add the exponents. So in this case, it would be 4 to the, what is -3 plus 2 is -1. And then go one more step. A negative exponent creates a reciprocal, so it's really just 1 over 4. So that's another way of coming to the answer, looking at the rules of exponents. All right, last one, D. I'm going to just rewrite it so you see it. So D is xy all to the third over xy to the third. Make sure that's what it says, yes. So remember that exponent of 3, it is affecting both the x and y because of the parentheses. That exponent of 3 only affects the y because the x is not in parentheses. The 3 does not affect the x. So if I'm going to write this out, this is xy times xy times xy, right? Because it's xy all to the third. This one would be x times y times y times y because it's the 3 is only affecting that y. So I can simplify this by crossing out some giant 1's. That set of x's crosses out, that set of y's. There's a set of y's there and a set of y's there. Now, what do I have left? I have nothing on the bottom. Well, I shouldn't say nothing. I have 1, right? 1 times 1 times 1 is 1. On the top, I just have 2 x's, so it's x squared. So my final answer just would be x squared. Okay? All right. There you go.